Unit 7.4, a postulate for similar triangles. Remember congruent triangles? We learned that we could prove that two triangles were congruent by side, 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 angle, side, angle, side, and hypotenuse leg. And every time it said side or angle, it meant equal sides or equal angles. Well, in similar figures, the angles are equal, but the sides are not. The sides are in proportion. So we're going to have things like side, 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 angle, side, but then we're going to have angle, angle. When it says angle in similarity, it means angle equal angle. If it says sides in similarity, side, then it means proportional, okay? Because the sides of similar figures are not equal. The sides of similar figures are in proportion. Okay, we'll learn what that means as we continue. But the first rule, the first way to prove that two triangles are similar is angle-angle similarity postulate. It says if two angles of one triangle are equal to two angles of another, then the triangles are similar by angle-angle. Now you may say, well, why don't we use all three? Well, there's another rule that says if two angles of one triangle equal two angles of another, then the third angles are automatically equal. So we don't have to try to prove three sets of angles equal. We prove two pairs of angles equal, and the other pair are automatically equal. All right. Example. Are the two triangles similar? If they are, name the similarity. Well, they gave us this stuff. Where's the equal angles? Well, they gave us parallel lines. So now we got to use our parallel line stuff. If two lines are parallel, then alternate interior angles are equal. They make the letter Z. Corresponding angles are equal. They make the letter F. Same side interior angles are supplementary. They make the letter C. Or if a transversal was perpendicular to one, it would be perpendicular to the other. Now we know that angle B is equal to angle D because they're corresponding angles. See the upside down F? According to the true definition, angle B is in the top right hand position and angle D is in the top right hand position. So they're in corresponding positions relative to the two lines. So we can say that angle ABC is equal to angle D. We can name angle D with only one letter because there's only one angle at the vertex D. I'm having trouble getting this where I want it. Angle ACB, angle ACB, which is this angle, is a corresponding angle with angle E. And we know that those are equal because the two lines are parallel. So angle ACB is equal to angle E because they're corresponding. So you got two angles of the one equal two angles of another, so the triangles are similar by angle-angle similarity. Now we want to name that similarity. A is equal to A, it's actually equal to itself by reflexive property. Angle B was equal to angle D, so we'll put B and D both in the middle. I'll keep it color-coded. Let me use blue, excuse me, if I can know my colors. Those were corresponding, and then C and E were corresponding, and so C is last, therefore E is last. So remember, when you name that similarity, you must name corresponding parts in order. Now, we know that the sum of the angles of a triangle is 180. So if we take 180 minus the two angles we know, we'll get the one that we didn't know, 50. Same for this. If we take 180 minus the ones we do know, we get the one we do not know, 70. So it comes out that angle I is 70 degrees and angle G is 50 degrees. And so we have all the angles of one equal all the angles of another. All we need is two, and then obviously the thirds are equal. So they are similar by angle similarity. Now F is 60, so it's got to go with K, which is 60, because we have to name corresponding parts in order. H is 70, so it goes with the I, which is 70. Again, you just can't say left goes to left. It might have been spun around. And then G, which is 50, would go with J, which is 50. And so we name the similarity, and they're similar by angle similarity. Let's see how we got that. Well, number 3, what we've got marked here is we've got that two sides of a triangle are equal. We know because of the isosceles triangle stuff that if two sides of a triangle are equal, then the angles opposite those equal sides are equal. So these angles are equal. We know over here in this triangle that if these two sides are marked equal, then the angles opposite those equal sides are equal, and I'm trying to put two arcs there. So if two sides of a triangle are equal, then the angles opposite those equal sides are equal. So we know that a triangle is 180, and we've got that this angle M is 30, so 180 minus 30 divided by 2 would give us the two bottom angles. Angle L is equal to angle N, and 180 minus 30 is 150, divided by 2 is 75, so those would be 75 degrees apiece. The same thing's going to happen over here on the other one. If we take 180 minus the 30, we would get 150 divided by 2. It's 75 apiece. So angle O is equal to angle Q is equal to 75 degrees. So it turns out that all of the angles of one are equal to all of the angles of another, and so they're similar by angle similarity. Now, the L of this one could actually correspond to the O or the Q, because O and Q are the same. So it's not really going to matter. We'll just leave it without being flipped and say that L is equal to O. M was 30, so it would go with the P, which is 30. And then the N would go with the Q. Or again, we could have reversed those, but we'll just make it where it didn't flip this time. And so those are similar by angle similarity. Any questions on the notes part of 7.4? Okay, so that takes us to 7.4 daily work. We want to name the similarity if they're similar. If they're not, we just want to say we can't reach any conclusion. Okay, so let's just start with number 1. We have that these lines are parallel. Let me orient my smartboard again. It's off again. Just a moment. We're back. Okay, so we've got the parallel lines indicated here by the arrows in the middle. If two lines are parallel, then alternate inch angles are equal, corresponding angles are equal. Angle B, that angle ABC, and that angle D are corresponding. And this angle ACB and angle E are corresponding. Therefore, we can say that these are similar by angle, because we just proved that two angles of one equal two angles of another. Angle A of the top triangle and angle A of the whole triangle is the exact same angle. It's equal to itself by reflexive. Angle B was equal to angle D because they were corresponding, so we're going to put B and D in the middle. Angle C is last. It was equal to angle E. It was corresponding to it, so E goes last. Sorry. We want to find AD. AD. Now, we're going to use a proportion. The pair we know both of is bottom of little to bottom of big. So we're going to put bottom of little to bottom of big. And then we want to find AD. Now, AD is left side of big triangle. We've got bottom of little, bottom of big, so we would need left side of little, which is 3, to left side of big, which is that whole side AD. See that? Bottom of little over bottom of big goes with left side of little to left side of big. And then to solve that proportion, we cross multiply. I'm going to clean up some space here. And so we cross multiply. 5 times 3 is 15, is equal to AD times 4, which is 4AD. We're going to undo multiplication by division. And so we get AD is equal to 3 times 4 is 12. You'd have 3 left over, so you put your remainder 3 over divisor 4. So 3 3/4 or 3.75, either way. See how we got that? Okay. Let's take a look at number 4. Number 4, we've got A is 60 and K is 60. We know that if that's true, those are altered at interior angles, so the lines are parallel. But we also know, see the blue ones I just put? We know that those are equal because vertical angles are equal. Angle A and angle K make a Z. They're alternate interior angles. So again, if those are, excuse me, got a catch in my back. If those are equal, then the lines are parallel because alternate interior angles are equal. And once we know that the lines are parallel because alternate interior angles are equal, we can say that this other pair of alternate interior angles are equal because the lines are parallel. And we know that the vertical angles are equal, so we basically know that all of the angles of one are equal to all of the angles of another, so we say they're congruent by angle-angle similarity, angle-angle similarity. Now the A was equal to the K, they were both 60 degrees. So since A was first, we'll put K first. B was equal to J down here because they're the other alternate interior. So since B is in the middle, we're going to put J in the middle. And then those vertical angles were both C right here. And so we'll put C equals C. We're looking for JC. We're looking for JC. So we could use a proportion or we could use dimensional analysis. Let's just use dimensional analysis this time. This is my B that disappeared here. If I want to find JC, I know that it goes with BC because BC is the last 2 letters and JC is the last 2 letters. So BC goes with JC. Let's use dimensional analysis because I used proportions on the other one. When I use dimensional analysis, I'm going to take my start times my scale, and my start is going to be the partner to the one I'm looking for. Now I'm looking for JC, and its partner is the 5, so I'm going to start with the 5. And I'm going to multiply by my scale. Now I'm going from little to big. See that? Little 5 to big. Little to big means I'm going to scale down. Well, what about my scale factor? My scale factor's got to be a pair I know both of. This 3AC, first and last letter, goes to KC, first and last letter. And so the 3 goes to the 5. So my scale factor is either 3/5 or 5/3. I'm scaling down, which means I need to get smaller, and so I'm going to use the 3/5. Understand that? I'm scaling, I'm not scaling down. I'm going from, I'm going to JC. That's the big one. I'm going from the little one to the big one. I apologize. We're not scaling down. We're scaling up. So I don't use the little version. I use the big version, 5/3. I apologize for that. So when I multiply, I would get 25/3, which will be 8 1/3. Any questions on number 4? I tried to mess up. You've got to be very careful with your scale factor, okay? We're going to leave those for you to work out on your own. It says John wants to know. We'll look at number 7. We'll get you kind of started here. John wants to know how tall a tree is, so he walks in front of it until the end of his shadow is at the end of the tree's shadow. Now, this actually works. If John is 6 feet tall, then his shadow is 9 feet long, and the tree shadow is 18 feet long, then how tall is the tree? So those are all measurable things. John is 6 feet tall. His shadow is 9 feet tall. The shadow of the tree is 18 feet. Then we want to know how tall is the tree. So we can put John over John's shadow equal tree over tree shadow, or any other way of proportional work. We could put John over tree equal John's shadow over tree shadow. Okay? As long as you do the same thing twice, you see. So I'm just going to put John over John's shadow is equal to tree over tree shadow. So John 6 over John's shadow 9 is equal to tree we don't know over tree shadow 18. Now, why does this work? Well, we're making the assumption here that the tree is perpendicular to the ground and that John is perpendicular to the ground. So we have one pair of equal angles. And then this angle of elevation of the sun, as we would call it, right here, that's the same angle in the little triangle as the big one. And so we have all of the angles of one equal all of the angles of another. So the triangles are similar by angle, therefore the sides are in proportion. So we set up a proportion with John over John shadow, tree over tree shadow. And then we're going to cross multiply. 6 times 18 is 108, is equal to 9 times t, which is 9t. Divide by 9, and we get t is equal, whoops, we get t, let's try to get t again. T is equal to 12. And you may say, well, I could have made equivalent fractions up here. 9 times what is 18, 2, so 6 times 2 is 12. Correct, you could make equivalent fractions. That would be kind of like scaling up, wouldn't it? Any questions on that? Okay. And we're going to let you work on those last two yourself. Here's some discovery learning. Remember, what you learn is going to be the rules for the next page. So we're learning two more rules in this discovery. Again, we want you to draw accurately, but we are going to let you know again that the rules for 7.5 are discovered in the end of the homework in 7.4. So you can look here at the rules and kind of know what to put for those answers.